Good day everyone. Today let me present to you some examples of speed and velocity. Now, how do speed and velocity have differences? Problem number 1. What is the speed of a rocket that travels 10,000 meters in 60 seconds? As you can see, the problem here is the speed of the rocket. Now let us proceed to the solution. Let me present first the formula for the speed. Speed is equal to the total distance over time elapsed. Here in the problem, the total distance of a rocket is equal to 10,000 meters within 60 seconds. Therefore, the time elapsed is equal to 60 seconds. The values are all set and all we have to do is substitute it into the formula. We have a speed is equal to 10,000 meters over 60 seconds. Then the result will be equal to 166.667 meters per second. Therefore, the speed of a rocket is equal to 166.667 meters per second. Let us proceed to the next example, problem number 2. How long will it take if you travel 500 kilometers with an average speed of 100 meters per second? Now, in this problem, we will find an object's equivalent time travel including the distance concerning its average speed. Now, let us proceed to solution. Now, what is the formula for average speed? Average speed is the ratio of the total distance to the total time. Now, from the formula, we will reciprocate from average speed to time travel. Therefore, the result of time will be equal to the total distance over average speed. Now, let us proceed to substitution. Substitute the given to the formula, but we should first observe the units of the problem. Distance is in terms of kilometer, and average speed is in terms of meters per second. It is 2 as our reference for the conversion of units so that we could proceed directly to the substitution process. Now we try to use the conversion of kilometer to a meter. There are 1,000 meters in every 1 kilometer. Therefore, we will convert the 500 kilometer into a meter or give a value of 500 times 10 raised to 3 or that is equal to 500,000 meters. Then we can now proceed to the substitution process. Now substitute the value of total distance which is equal to 500,000 meters with an average speed of 100 meters per second. Then the result is equal to 5,000 seconds. Now if you try to convert seconds to an hour, this could be right up like this one. 500 seconds multiplied by this factor represents the conversion of seconds into an hour, which is equal to 3,600 seconds in every 1 hour. And given the result of 1.3889 hours. Therefore, this problem, 5,000 seconds, is also the same if we use the 1.3889 hours. Either we can use 2 as the final answer based on this problem only. Example number 3. A person walks 150 meters in 10 minutes, then 200 meters in 15 minutes, and finally 40 meters in 4 minutes. Now find its average speed. How do we solve for the average speed? Let us proceed to the solution. The formula for average speed is equal to the total distance over total time. From the formula, let us calculate first the total distance and total time of the problem. Total distance is equal to the summation of the distance traveled, which is equivalent to 390 meters, and the total time is equal to 29 minutes. As we observed, units are in meters and minutes. Since the distance is in the SI unit, then the time traveled must also be the same as the distance unit, and it should be seconds for the unit. That will give us a result of a meter per second. But how can we do this? Let us convert the unit of time from minutes to seconds. From 29 minutes, let us multiply it by the factor of 60 seconds per minute, which will give us a result of 1740 seconds. Now we can now directly substitute the values to the formula. The average speed is equal to 390 meters as the total distance and 1740 seconds as the total time traveled. Now the answer is 0.224 meter per second as the average speed of the person walks. Now let us try another type of example. Problem number 4. A person walks 500 meters due north, then 600 meters due east. If the entire walk takes 1,200 seconds, find the person's average velocity. Now let us proceed to the solution. According to the rules of average velocity is the displacement divided by the time elapsed, whereas displacement is also a vector that obeys the addition vector rules. Now for this problem, we need to add each displacement to get the total displacement. From the figure shown, the change in x sub 1 is equal to 500 meters, while the change in x sub 2 is equal to 600 meters. Now we need to solve the displacement before we can proceed to the formula. As we observe from the figure, it represents a right triangle, and we can now use the formula for the right triangle. The total displacement or change in x is equal to the square root of two squares, which is this change in x sub 1 plus the change in x sub 2 with magnitude. Then substitute the values to the formula. The total displacement is now 781.025 meters with a time elapsed of 1,200 seconds. Now the given are all set. We can now substitute the solved values to the original formula of average velocity. The result will be equal to 0.65 meters per second as the total magnitude average velocity. Problem number 5. An object moves along a straight line. First, it travels at a velocity of 15 meters per second for 10 seconds, and then continues in the same direction at 20 meters per second for 10 seconds. Now, what is the average speed? Let us proceed to the solution. Velocity is displacement divided by time elapsed. In this problem, an object moves two stages with two different displacements. Now, to find the total displacement, we need to add the two displacements and also the same procedure to a specified time. Now, let us calculate the total displacement. From the velocity formula, displacement is equal to velocity times time. Now, the result of the first travel is 150 meters, while the second one is 200 meters. We can now substitute the values to the formula that we will use. Now, average velocity is equal to the total displacement over the total time of two travels. Then we get the result of 17.5 meter per second as the average velocity of the two travels. We'll proceed to our last example. Problem number 6. A car travels one-fourth of its path with a constant velocity of 20 meters per second and the remaining with a constant velocity denoted as v sub 2. Now, if the total average velocity across the whole path is 35 meters per second, then find the second velocity. Now, how to solve this one? Proceed to solution. We will use the formula for an average velocity. Now, for the displacement, let the length of the path be denoted as L. We denote the total displacement as x sub 1 and x sub 2, but for the time elapsed, we will create a new formula concerning time. So we use displacement over velocity. Then we will now substitute the values for the new formula. Substitute the value of the average velocity as stated in the problem. The first displacement has only one-fourth of total travel while the second is remaining or equal to three-fourths of the total travel. For the time elapsed, use the current value of displacement over the specified velocity. As we observe, there is no value of velocity for the remaining three-fourths of the total travel displacement, and that is what we are looking for. We simply use the cross multiplication process or directly use the scientific calculator to solve this. Then the result is 46.667 meter per second as the value of constant velocity or the v sub 2. I hope you've learned something from today's video. Have a great day everyone and keep safe always.